Good luck, Grant, with this one. And the front two on page 5-8. Here's the answers. There's an identity. Good luck. Right, and it's up there in case you lose it somewhere in the middle.
So when you try and find it in rectangular form, you just repeat like the radius that you get, right? With cosine and sine.
Right. The same angle for both, right? It's written in CIS form. It's a good question. Well, I could make up something, but it's not true. Or make up. I will, at the end of this, we're going to learn something called Dave Watt's rule, which is an example of how you can use this stuff. It's really kind of, it does some things. Like at the very start of this semester, I said, hey, x cubed equals 1. What's the answer? And everybody said, oh, x equals 1, right? I said, yes, that's one answer. It's x cubed. Where are the other two? Dave Watt's rule lets us find the other two. So now, how useful is that if you're going to flip burgers at McDonald's? Not even close to useful. Okay, so, let's try and press a girlfriend or something. A boyfriend, not judging. Okay, so that's where we're going, but we still got a couple steps before we get there. All right, let's do this. So I got, identity, 6 divided by 2, cis, 3 pi over 4 minus pi over 4. That was really badly written. All right, so I get 3 cis pi over 2, correct?
Yeah.
So that's my cis form. And if I want to go rectangular, I would go 3 cosine pi over 2 plus I sine pi over 2. So then cosine of pi over 2 is? No. Cis is always plus. This is always plus. It's minus here in the identity to get to this point. Once in the cis form is always a plus form. Always plus.
So when you switch to rectangular form or polar, it's still.
When I start polar, when I switch to rectangular, I'm going to have to make it's always going to be cosine plus I sine. Always plus. It's the minus is when you're trying to resolve the two multiplied and divided together, right?
Yeah.
Multiply and divided together. That's a great sentence. Cosine of pi over 2, I get 0 plus I times 1. So I get 3 times 0, which is 0, plus 3 times I, which is I. 3i, so I get 3i.
I did it right.
I'll do number 2 as well.
Was it?
Yes.
You distribute the 3, right?
Yep, distribute 3.
Wait, let us do number 2.
Do number 2.
So you have 1/2 divided by hit 100.
It is amazing. So plus I sine. Oh, actually, I don't want to waste all that room. Let's just go right to cis form.
Oh.
So 1/2 cis pi over 3 divided by 3 cis
How is
pi over 6.
How did you get 1/2? Because I did pi over 3.
They said 1/2 in the front. I'm writing down the problem. I'm not doing it yet.
Oh.
This 1/2 divided by 3 cis pi over 3 minus pi over 6. Supposed to be good? Common denominator, I need to make this top bottom times 2. 1/2, I'm going to write this as 3 over 1 so I can flip and multiply in a moment. Cis 2 pi over 6 minus pi over 6. Flip and multiply, I get 1 over 6 cis pi over 6. That's my cis form. It's hard, yeah. It's harder than the previous chapter. Chapter 4 was basically an algebra chapter that Lily describes as a trig chapter. This is something completely different. Okay. I did say it was easier. So this is root 3 over 2.
Okay, what do you do from there now?
Distributed property, multiply it right in. So I get root 3 over 12 plus 112i.
You don't put that together.
I deny that I can't.
Just kidding. I did it right.
Can it be I-112 or something? Does it matter where the I goes?
It'd be okay to put I-112.